2025 A-Level Combined Mathematics Paper 1 Part B, question number 16, Part 2. As I discussed in the previous video, question number 16 doesn't actually have any Part A's or Part B's unlike the other questions. But if I did the entire question in one video, then the video would be too long. To fix this, what I did was to break this question into two pieces, Part 1, which is the first 3 lines, and Part 2, which is the second 4 lines. So Part 1 has all to do with straight lines in the coordinate plane, and the video on Part 1 is this video on the top right here. It was discussed in the previous video. Part 2 is going to be discussed in this video, and Part 2 is all about circles in the Cartesian coordinate plane. So now let's take a look at the second part of the question and complete question number 16. So the first part of the question says, write down the equation of the circle C1 that touches all three sides of the triangle OAB. Now the triangle OAB, as in the points O, A and B, were described in the previous question. Here we can see O is the origin, A is the point 1, 2 and B is the point 5 over 2, 5 over 4. So these 3 points make a triangle, and this circle C1 is the circle that touches all three sides of the triangle OAB. Now by touches, of course, we need to understand that what we're talking about here is the incircle of the triangle OAB, as in the circle that is tangential, as in the lines OA, AB and OB are tangent to the circle, which is the circle centered somewhere in the middle at the point that is correspondent to the intersection of each of the angle bisectors of each of the angles within our triangle. So we're going to actually be using that fact later to actually find C1. But moving on to the next part of the question, if we read, it says, suppose that the circle C1 touches OA and AB at the points E and F respectively. So basically we're defining these points. The point E is the point on OA at which the line OA is tangent to the circle C1, and the point F is the point on AB where AB is tangent to C1. Now given this, we're then asked to show that the equation of the circle C2 that goes through the points A, E and F is given by 4x squared plus 4y squared minus 9x minus 13y plus 15 equals 0. And then finally we are asked to determine whether the intersection of the circles C1 and C2 is orthogonal. So to start with this question, what we're going to do first is to consider the situation that we have and understand that in the previous question we were actually building up certain bits of data that we can use to solve this question. So if we consider the situation, I've already pre-drawn most of it. Here you can see I have the points O, A and B previously marked, and I also have the point D, which is the intersection of the two angular bisectors of the angles AOB and OAB. So here we can see L1 and L2 intersect at this point right here, which is the point D. I've also additionally drawn this circle here, which is the incircle of the triangle OAB, as in the circle that touches each of the sides of the triangle OAB at a single point. So here we can see this point, and this point are the 3 contact points. Now out of these 3 contact points in the previous question above, we remember that we had names for this point right here and this point right here. The intersection of the line OA and the circle was to be called E, and the intersection of this line AB and the circle was to be called F. We didn't have a name for this one, but we could call it G, but for now I'm not going to call it anything, I'm just going to leave it as it is. So now we have these points E, F and the center point D. Now an important thing that you need to note is that this center point D is the intersection of 2 of the angle bisectors of a triangle. And as we know, all 3 angle bisectors of the triangle will pass to the same central point, and that central point is going to be the center of the incircle of that triangle. So in this case we have OAB, and these 2 lines L1 and L2 are the angle bisectors of the 2 corresponding angles, which means that the third angle bisector is also going to pass through that same exact point, and these 3 lines passing through this point means that this point is going to be the center of the incircle, which is exactly this circle that we've drawn here. So in the question they call this circle C1, so I'm going to do that. I'm going to label this circle C1, and then I'm going to establish the connection between the intersection of the lines L1, L2 as in the point D and the circle C1. So if I go down, what I'm going to write first is that since C1 is the incircle of triangle, let's say OAB and L1 and L2 are angle bisectors of that same triangle, triangle OAB, that intersect at D. With all of this information, we know that the center of the circle C1 is actually exact with the point D. So we can write down here that the center of C1 is D, which if you recall was given by 5 divided by 4, 5 divided by 4 in the question. So now we know exactly where the center of the circle C1 is. Now, if we consider the points E and F now, and we consider the lines, which I'm actually going to move this D out of the way. I'm going to move the D here so that I can draw these lines. If we consider the lines ED and FD, this line and this line, these two lines we now know are radii of the circle C1. So therefore, this is a radius, this is a radius, and we also know that since this is tangent, this is perpendicular, and this is perpendicular. Now from this, note that it also means that the radius R is the perpendicular distance of the point D to the line OA, and it is also the perpendicular distance of the point D to the line AB. Now, recall in the previous question that we found that the perpendicular distance D of D from OA is equal. Actually, it seems I made a typing mistake here as well. It should be from OA. Anyway, the perpendicular distance of the point D from the line OA is equal to the square root of 5 over 4. This means that the radius of the circle from above, we can say from above, R is equal to square root of 5 over 4, or the radius of the circle is equal to the perpendicular distance of the point D from the line OA. So now with that we have both the center of the circle and the radius of the circle. Now this is sufficient for us to find the equation of the circle. All I do now is to say that C1 is given by, and then we can write out the center difference form of the circle. So we know that if we consider the difference of x coordinates and difference of y coordinates, any point x on the circle minus the central x coordinate, which is going to be 5 over 4 squared, plus any y coordinate on the circle minus the central y coordinate, which is 5 over 4 squared, added together is going to be equal to the radius squared. Simplifying this down, we can see that if we expand these two sums up and we substitute r as being equal to square root of 5 over 4, we are going to get x squared minus 5 over 2x plus y squared minus 5 over 2y, and additionally we're going to get this is going to be 25 over 16, so we have plus 25 over 16, and this is also going to give us plus 25 over 16 is equal to, and r squared is equal to square root of 5 over 4 whole thing squared, which is going to be 5 over 16. Now if we clean everything up here, we can see we get C1 being given by x squared plus y squared minus 5 over 2x minus 5 over 2y, and then simplifying the constant terms, we can see a common denominator of 16, so divide by 16, and here we have 25 plus 25 minus 5, which is going to give us 50 minus 5 or 45. That's going to be equal to 0. So therefore this circle is the circle given by x squared plus y squared minus 5 over 2x minus 5 over 2y plus 45 over 16 equals 0. So with that, we have found the equation of the circle C1. Now for the next part of the question, after we solve the equation of the circle C1, what we need to do next is to consider the points E and F and show that the equation of the circle C2 that goes to the points A, E and F is given by this. Now there are multiple ways to do this. One simple way that you could do this is to find the coordinates of point E and point F, and then you could do again the angle bisector method that we had for the previous question, where you find the angle bisectors of A, E, F, and maybe A, F, E angles, and then find the intersection, call that the center point of your new circle C2, and so on and so forth. But there is an easier way to do this. The easier way to do this is to realize that these 2 points, E and F, are common to the circles C1 and C2. Now as you know from the previous video as well, we covered this in our Cartesian circles video. If we have 2 circles, that have common points E and F, for example, then if you consider the line that connects the points E and F in standard form as in AX plus BY plus C form, which I'm going to represent with EF, then C2 is going to be given by C1 plus some constant lambda times that line EF. So C2 is some x squared plus y squared plus 2fx plus 2gy plus c equals 0 form. C1 is also of that same form, and EF is of the form ax plus by plus c equals 0. Given this, circle C2 is going to be given by circle C1 plus lambda times the equation of the line between the two common points of the two circles. So we're not going to be proving this in this video, of course, we're just going to be using it. So using this, if we can find the equation of the line EF, we can then use the fact that the equation of circle C2 is going to be equation of circle C1 plus lambda times EF, and then we can use some other known property of that circle in order to find the value of lambda and therefore find the equation of the circle. So if we go down here and consider the line EF, this line EF can be found very easily by the fact that if we consider the point A and this circle here, we can see that if you consider the circle C1 and the point A, the tangents of this point A to the circle C1 are touching the circle C1 by definition, as we defined previously in the previous question, at points E and F. So from this we know that the points E and F create a line which is the chord of contact of the external point A to the circle C1. So this line here is the chord of contact of the point A to the circle C1. Now as we know, any chord of contact to a circle of the form, let's go down here and write that down actually. For a circle C given by x squared plus y squared plus 2gx plus 2fy plus c equals 0 form, the chord of contact from an external point, say x0, y0, is given by the equation x0 plus y0 plus g x plus x0 plus f y plus y0 plus c equals 0. So we can use this fact here, which I'm actually let's put this in a box first. We can use this fact in order to find the equation of the chord of contact from the external point A to the circle C1, which is going to be the line EF. So we can say therefore the line EF is given by, and we can find its equation. So if you consider the formula that we have, x0, y0 is going to be the point A, which is 1, 2. So therefore x0 is 1 and y0 is 2. So if we substitute into here, we can see we're going to get x times x0, which is x times 1, or x, plus y times y0, which is y times 2, so 2y, plus g times x plus x0, I'm going to write x plus x0 part, which is going to be x plus 1, plus f times y plus y0, which I'm going to leave f blank and write y plus 2, plus c equals 0. So if we consider the rest of the constants, g, f and c, in the equation of c1, we can see this is going to be 2gx, which means g is going to be negative 5 over 4. Similarly, f is also going to be negative 5 over 4, so therefore we can substitute into here. I'm actually going to have to erase the pluses here. Erase this plus, erase this plus. G is going to be minus 5 divided by 4, and f is also going to be minus 5 divided by 4, because what we have here is 2 times g and 2 times f. So if 2 times g is equal to negative 5 over 2, then g must be equal to negative 5 over 4. Similarly, if 2 times f is equal to negative 5 over 2, then f must be equal to negative 5 over 4. And c is equal to 45 over 16. So therefore this is equal to 45 over 16, and all of this is equal to 0 is going to give us the line EF. Now if we simplify all of this down, we can see we get x minus 5 over 4x, which is going to be negative x over 4, and we get 2y minus 5 over 4y, which is going to be plus 3y over 4, and then we get minus 5 over 4 minus 5 over 4, a minus 5 over 2 and a plus 45 over 16 equals 0. Now if we simplify all of this by multiplying everything by 16, we can see we're going to get minus 4x plus 12y minus 20 minus 40 plus 45 equals 0. Simplifying all of this down, we can see if we can do this. We can multiply everything by negative 1 to get x to have positive coefficient. So we get 4x minus 12y, and then this simplifies down to, if we see, we have minus 40, which means this becomes plus 5. Plus 5 minus 20 is going to give us minus 15. So when you multiply everything by minus 1, that gives us plus 15 equals 0. So therefore EF is given by 4x minus 12y plus 15 equals 0. So now that we have EF, as we know, since C1 and C2, which I'll temporarily just mark C2. C2 is going to be a circle that looks a bit like this. This circle C2 here is going to also pass through the points E and F. So we can say, since C1 and C2 pass through the points E, F, C2 is going to be given by C1 plus lambda times EF, where of course lambda is some element of the real numbers. Now if we substitute into this, we're going to get that C2 is given by, and if we consider C1 was x squared plus y squared minus 5 over 2x minus 5 over 2y, and then plus 45 over 16 plus lambda times the line EF, which was 4x minus 12y plus 15, and this has to be equal to 0. So we have this equation right here. Now, if we consider the circle C2, additionally we also know that the circle C2 must pass through the point A, which is 1, 2. So we can go down here and we can say that since A, which is given by 1, 2, is on C2, and we can use the fact that since this point A is on C2, substituting the coordinates of A in here should give us the correct answer. So therefore, if we do that, we get that if we substitute x for 1 and y for 2, 1 squared plus 2 squared minus 5 over 2 times 1, which is going to be 5 over 2, minus 5 over 2 times 2, which is going to be 5, plus 45 divided by 16, plus lambda times, and then on the inside we get 4 times x, which is going to be 4 times 1, which is going to be 4, minus 12 times 2, which is going to be minus 24, plus 15 is equal to 0. Now if we clean all of this up, on the right hand side we have 4 minus 24, which is going to be minus 20, plus 15 is going to be a minus 5. So we have minus 5 lambda. Taking it to the other side, we have plus 5 lambda. So we have 5 lambda, which is equal to, and if we clean up everything else here, we have 1 squared plus 2 squared, which is going to be 1 plus 4, which is 5. The minus 5 can cancel for that, so we can cancel this for this, leaving us with minus 5 over 2 plus 45 over 16. So if we multiply the top and bottom here by 8, we can get minus 40 over 16 plus 45 over 16, which simplifies down to 5 over 16, which then gives us the lambda is equal to 1 over 16. So there we go. We've now found lambda. We can now go back up here and resubstitute the value of 1 over 16 of lambda into this equation in order to finally get the explicit equation for the circle C2. So if we substituting lambda, we can get that C2 is given by x squared plus y squared minus 5 over 2x minus 5 over 2y plus 45 over 16 plus 1 over 16 times the line EF, which is 4x minus 12y plus 15 equals 0. If we simplify this, we get x squared plus y squared. The x terms become minus 5 over 2x plus it's going to become 4x over 16 is going to become x over 4. So if we convert the common denominator of 4, we're going to get it's going to be a minus 10 over 4 plus 1 over 4. Minus 10 over 4 plus 1 over 4 is going to be minus 9x over 4. And then as for the y coordinates, we're going to get minus 5 over 2y and minus it's going to become 3 over 4. So minus 3 over 4, and if we convert this thing into a denominator of 4, we're going to have minus 10 over 4 plus negative 3 over 4, which is going to be minus 13y over 4. And then as the constant terms, we're going to have 45 divided by 16 plus 15 divided by 16, which is going to become 60 divided by 16, which we can divide out to become 15 over 4. So we have plus 15 over 4 equals 0. Now finally, if we multiply everything here by 4, we can see that C2 is given by 4x squared plus 4y squared minus 9x minus 13y plus 15 equals 0. Now if we go up, we will see that this value of C2, this equation of the formula of the circle C2, is exactly what we had in the question. If we go up to this page right here, we can see 4x squared plus 4y squared minus 9x minus 13y plus 15 equals 0. Now finally, the last part of the question says, determine whether the intersection of the circles C1 and C2 is orthogonal. Now for this we need to use our knowledge on the condition that if two circles, say x squared plus y squared plus 2gx plus 2fy plus c equals 0 and x squared plus y squared plus 2, let's say g prime x plus 2 f prime y plus c prime, let's say, equals 0 are two orthogonally intersecting circles, then we will have the condition that if you consider these coefficients 2 times g times g prime plus 2 times f prime is going to be equal to c plus c prime. So we need this condition to be the case if these two circles are intersecting orthogonally. Now we can write this as theory and apply it to this particular situation. So in this particular situation, if we consider the values that we have for the first circle C1, the coefficients that we had are 2g being equal to negative 5 over 2, meaning that g is equal to negative 5 over 4. Similarly, f is equal to negative 5 over 4 and c is equal to 45 over 16. So if we consider those 2 times, therefore if we consider let's say c1 and c2, on the left hand side we're going to consider 2 times g prime 2 times g prime plus 2 times f prime. We're going to have 2 times the first g times the second g plus 2 times the first f times the second f. The first g is going to be negative 5 over 4 and the first f is also going to be negative 5 over 4. If we consider the second one, however, in the second one we have the second g being equal to negative 9 over 4 times 2, since actually divide by 2, since 2g prime is equal to negative 9 over 4, meaning that g prime is equal to negative 9 over 8. Similarly, f prime is going to be equal to negative 9 over, this is negative 13 over 8. So we have negative 9 over 8 and negative 13 over 8. Now if you simplify this down, we can see we're going to get both of these are going to have a denominator of 16, so we can write divide by 16 and divide by 16. Both of these are going to be positive. On this one we're going to have 5 times 9 over 45, and on this one we're going to have 5 times 13, which is going to be 50 plus 15, which is 65. So you have 65 plus 45, which is going to be 110. So you have 110 over 16. Now if you come to the other side, c plus c prime is going to be equal to the sum of the two constants. Over here we can see the first constant is 15 over 4 and the second one is 45 over 16. So if you add them together, 45 over 16 plus 15 over 4 is going to be equal to common denominator of 16. So we have 45 over 16 as it is, plus divide by 16. We have 60 divided by 16. Adding them together, we can see this is going to be equal to 105 over 16. Now clearly if you compare these two values, 110 over 16 is not equal to 105 over 16. It's almost equal, but it's not equal. So since 110 over 16 not equal to 105 over 16, as in 2 times g prime plus 2 times f prime is not equal to c plus c prime, circles C1 and C2 are not orthogonal. So this is important. They are not orthogonal because the two sums on both sides are not equal to each other. So that's going to be the last part of this question, and that is going to be all that we have for this question. So now finally, let's discuss the marks awarded for this question. So considering the marks awarded at the start, when you derive the fact that the point D is going to be the center of the circle C1 and the radius of the circle is going to be equal to square root of 5 over 4, from the above that the perpendicular distance from D to the line OA is going to be equal to square root of 5 over 4, and then you use that information to write down the equation of the circle C1 as this, you're going to get 10 marks for that. So all of this work, 10 marks for writing the correct equation for the circle C1. When you then consider the line EF and realize that is the code of contact of the external point A and the circle C1, and then you use that to directly write down that formula, you get 10 marks. When you then simplify it down to get the form of AX plus BY plus C equals 0, you get 5 marks. When you then use the fact that since the circles C1 and C2 both have the common points E and F, if you consider the line EF, you can get this relationship right here, where the circle C2 is equal to the circle C1 plus lambda times the line EF equals 0, you get a 10 marks for that. When you then use the fact that the point A, which is 1, 2 is on C2, and you substitute in that value in order to simplify down and finally get that lambda is equal to 1 over 16. For finding lambda equals 1 over 16, you get 5 marks. Then after that, when you resubstitute lambda, simplify everything down and finally get C2 in the form that they gave in the question, you get a total of 10 marks. So this 10 marks is for all of this working and the final answer. Now after that, when you then consider the orthogonality of the circles and you consider this value here and this value here, as in 2 times G prime plus 2 times F prime and C plus C prime, you find the value of this thing right here, 2 times G prime plus 2 times F prime being equal to 110 over 16, you get 10 marks for all of that working. And then when you find the value of C plus C prime to be equal to 105 over 16, you get 5 marks for that. When you then show that these two values are not equal to each other, and hence, since them being equal to each other is the condition for orthogonality, they cannot be orthogonal, you get another 5 marks. So that is going to be all the marks awarded for this question and the end of this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.